Hello, welcome. This is Professor Ma, and this is the summary on the sections of trigonometry. Okay, the first few pages of the trigonometry's PowerPoints basically tells you the degree systems, which is the same as a time systems. We say one degree is cut into 60 minutes, and 1 minute is cut into 60 seconds. And of course, the circle 360 degrees. Okay, so the main thing is one round is 360 degrees, and half round is 180 degrees. And then the second system is the radian system. The radian systems, we first set the platform to be on the unit circles, that the circle of radius 1. So you will hear the word unit circle. Unit means length 1 in mathematics. Unit something means length 1. So here is a circle of length 1, radius. And we're playing around with, we can think of the angle is being formed by dialing these dials starting from here, and we dial over here, and here's the angle of theta. Okay, and so then, oops, let me go through one more time. So 1 round is 2 pi, half round is pi, a quarter round. Okay, so if I put in directions, in this case, going in the opposite direction, that is clockwise, is negative. So it's minus pi. So, okay, positive, negative. And then the radian measurements use the arc length, the theta that span cuts out of the unit circle. Use that length as the measurement. Why is that useful? It's because a lot of formulas concerning circle and the angles, like a pizza pie, a slice of pizza, and stuff like that, and the formula to calculate arc length and the areas can be it's much simpler in radian measurements. And here are the two formulas. One is for arc length. Arc length is r, the radius of the theta. The theta has to be in radian measurement. And here's the area. Same thing. In radian measurement. So if I have problems given in this problem in degree, basically the point of the problem, you need to convert to radians. Okay. And then go to the calculation, convert the radians and plug it into the formula. And these are the important angles of radian measurements. These are the axials. The x-axis is the even pi, even pi, 0 pi, 2 pi, 3 pi, integer pi. And then the vertical angles, 90 degree, minus 90 degree, they are pi over 2, minus pi over 2, etc. Then the 45 degree angles, those are pi over 4. And then you have the pi over 6 related angles, pi over 3 or pi over 6. And these are the hourly clock positions. Okay. So when you see pi over 6 or pi over 3 angles, and they are basically pointing at 2 o'clock, 3 o'clock, 1 o'clock, 2 o'clock, 4 o'clock, 5 o'clock, etc. And then this is the important part about you have to memorize this chart. And the way we get this chart is using these two triangular templates to calculate individual individual coordinate x and y. So put this one over here. That's why I get square root 2 over 2, square root 2 over 2. Okay. And from here, we can define, we're going to define what the trig values are. But before that, I want to point out the trig values, sine of something, cosine of something, tangent of something, depends on the positions more than the angles. So yes, depend on the position. The angle gives the position, but the trig value depends on the position. A lot of angles give the same positions. So all their trig values will be the same. So for example, pi over 3 and minus 5 pi over 3, same position for the dial. So they have the trig values, same trig values. Okay, and what are they? Here they are. Cosine is the x coordinate. Sine is the y coordinate, the vertical length. And then tangent is the tangent length of outside the circle. And cotangent is over the top. So these are the geometries of position related to the unit circles and the trig functions. Okay, so leave this up to you to as exercise. Same as this. Okay. Once we define those trig values, and then since the unit circle has an equation x squared y squared to 1, I can replace the x and y by cosine and sine. Give them a different name, and then basically this trig formulas basically are these equations in formulas in x and y, but with different names, cosine and sine. Okay. So we have from over here, we will have another formula, 1 plus, okay, I believe it's cotangent square of theta, and this is cosecant square. So here's another formula. Here's a formula. So after we play, it's a new name. Okay. So there are a lot of formulas because the relationship between x and y. How do we remember them? And here's a trick. The trig wheel. Okay, has two sides, regular sides, and then the cosides. Sine, cosine, tangent, cotangent, secant, cosecant. And the first batch of rules using these trig wheels are the divisions or multiplication rule. The multiplication rule says the two outside one multiply give you the right in the middle. Or division rule says if I take 3 steps, 1, it's going to be 2 divided by, if I go up there, 3. Okay. So 1, 2, 3. If I take 3 steps, no turning corner, I can go straight. So for instance, the reciprocal rule says secant of A is equal to 1 divided by cosine. If I go straight, 1, 2, 3. These are the division rules and multiplication rules. Okay, so here are some examples coming out of these division. More importantly is those square sum relation, and these wheels give you the 3 square sum relationship. There are 3 upside down triangles, and these give you the 3 square sum relationships. Okay, the top 2 squares give you the bottom one square. So tangent square plus 1 square is secant square. Okay, I go around that. This circle is just a tool to memorize these formulas. Okay. Okay. At this point, before I leave this formula, I want to point out these are the sum, the square sums formula. But if I move a term, then the formula look different. If I treat it as a different sine square, right? Then these can be factored. 1 plus cosine, 1 minus cosine, multiply together sine squares. Okay, and these patterns of using difference of square, you can extract a lot of different versions from here. Okay, using get them into a square minus b square equal to c square versions. Okay, and that's the point about talking about this is a lot of time when the problem will have part of these, and the procedure is to multiply to it by the conjugates to obtain that one. Okay, of course I have to do it legally, so I just want to point out this the algebra in the square sum, square difference formulas. Then you have given two angles. Now, if we're dealing two, we notice everything on top of the formula we're dealing with the same angle rate. Now, suppose I have two different angles, then what are the formula? These are the formulas that are the important one, most important one. Okay, so this one, for instance, is a sine of. Let me just point out the most important one. The most important one is this one. Okay, AB. Cosine A minus B is cosine A cosine B plus, okay, sine A sine B. Okay. Very important, this formula. This formula give rise to all the rest formulas, all the other formulas. Okay. And let me see, that's about it. And then here's a summary of the formulas from what I just said. That this one is equal to cosine A plus. This one gives rise to the minus one, then give rise to this one from here, then this gives to this, and so on. And here is the arguments. I give the arguments about why is that true. And it's a geometry argument, a distance. And basically, this the distance from here to here, it's going to be the same if I were to move these angles back here, rotate them into by minus 8. So into that position. That is, rotate the two angles into that position, but the distance will still be the same. Okay, and the coordinate of this point, this distance, and that distance the same. And I equate them, and then the formula pops out of it. And here's a calculation for it. Okay, here's a picture. I basically want to find out cosine is of the angle. Here's angle A minus B. I want to cosine that. I want to know what the x coordinate of that point is after the rotations. And then write down the distance d, and then I'll pop that formula. Once you have that formula, we get all the rest of it. Okay. And finally, these are the picture for the trigonometric functions. And yes, these are the list of formulas we'll use throughout the class when we get into trigonometry, trigonometric functions. Yeah, that's it. Okay, have a nice evening. Bye-bye. Oh, good enough.